Hi, welcome to the section of MapReduce. In this section, we'll be looking at how to write a MapReduce using some programming language called Python. We have a concept called streaming in MapReduce, using which we can write our MapReduce using Python. So let's look at a mapper Python code and a reducer Python code, and how do we execute that using a streaming jar file. We got to use something called a streaming jar file in order to execute your mapper and reducer using Python. The first thing is your mapper code. Let's open our mapper code and see what are all the things that we require. So I have something called user bin Python. As we have seen, this is a preprocessor directive which shows the code that it has to go to user bin path to have to execute this particular code, because Python is installed in user bin path. And we are looking at something called import sys. This is an inbuilt Python module which allows you to use some inbuilt features like reading and standard input data. We'll see how to read and data in the standard input, or the input in the standard input. So we are importing sys and we have our preprocessor directive. Let's come to our for loop. In this for loop, we are writing something like for line in standard input, right? Line equal to line dot strip. So this for loop will iterate through each and every line in the standard input, and it will strip the spaces. So it will strip the leading and trailing spaces in the data which we are passing as an input. For example, if I am passing hello world, if there are any spaces, trailing and leading spaces in the hello world, it will strip the spaces, because we don't need the spaces, right? And then it will split them into words. By using space as a default delimiter, it will split them into words using an inbuilt Python function called split. And the words will be stored in words array, or a words list, we call it as, or a tuple in Python language. And we'll take each word in that particular words tuple and we'll append a 1. That's what we do in our MapReduce. That's what we have seen in Java as well. We'll take a word and we'll append a 1 to each of the word, right? So that's what I'm doing using my Python as well. I'm taking a word and I am appending a 1 to each of my word, right? So it will print word tab 1. Okay, so let's test my code. I'll take something called vim sample.txt. Hi, I'm a Cloudera developer. I'm using this particular word once again, and I'm printing something called hello world, and I'll copy it and paste it. I've made some sample file here, just saving it. Okay, I'll just display this contents of the file, and I'll pipe it as an input to my mapper code. So in order to execute my mapper code, I'm using something called Python, because the Python is an keyword which you had to use in order to execute a Python code. Like we do for our shell scripts, we use sh as a keyword, right? For Python, we use Python as a keyword to execute your Python code. There it is. I got all the contents split into words, and I have appended a 1 to each of my word. Okay, that's what I do it in Java as well. And we have discussed the same thing in our architecture as well. That's what we are doing here. And let's look at now the reducer code and see what my reducer is doing here. Even reducer, it has something like a preprocessor directive, like a mapper has, because even it has to go to user bin path to execute this particular Python code. Because in the user bin path itself, my Python code is actually executed, or actually installed, I'm sorry. And then I'm importing sys, because I got to read my standard input, and I'm declaring an dictionary here. Word to count is a dictionary. We know that. I mean, when we declare something with the curly braces, like we discussed in our Python session, when we are declaring something with curly braces, it's nothing but a dictionary. When you are declaring something with an square braces, it would be nothing but a list in Python. Okay, so for each line in the standard input, again we are doing the same thing. We are stripping the spaces, right? And we are stripping the spaces. Next, what we are doing, we are splitting it based on tab delimiter. When tab is there, we are splitting it, word and count. Count will be 1 for every word, like we discussed, like we had printed in our mapper code. It will be 1 for each of the word. Now, I'm converting this count into int. I'm just doing a typecasting here. To make sure we are not getting any other things, any other data types into my count variable, right? That's why I'm using try catch block. If there is any error, it will be easy to trace it. So I'm using a try catch block here. And then what am I doing? For each word, right? For example, if my input is hello world to the mapper, the output would be hello comma 1 and world comma 1. And hello comma 1 world comma 1, right? So after the mapper phase, there will be something called a sort and shuffling. So what I'll get is the similar keys together, hello comma 1, world comma 1 and world comma 1, right? Let's assume this reducer code is executed for the piece of key which is hello comma 1, hello comma 1. What happens here when the word is hello comma 1, right? Okay, first what happens here is we have word which is hello and count as 1, right? So it checks here. What it checks? Word to count of hello, but here initially we are initialized it as something which is null, nothing is there, right? So word to count of hello plus the count. Okay, so word to count of word which is my hello plus the count. The count is 1. So what happens is word to count of hello. Do we have that in this word to count? Because it is initialized with null. So we don't have it, right? So it will go to the except block. If we have something called word to count of hello comma 1 in our dictionary, then this particular situation might have been worth. As we have null in our first iteration, it will enter into the except block. So what we have here, what are we doing here? In this we are initializing hello with something called 1. So our dictionary will have one entry which is hello comma 1. The dictionary is nothing but word to count, right? So in my second iteration, if hello comma 1 comes again, what happens is in your try block itself that will be handled, because a word to count of hello, yes, it's there. In my first entry it's there as hello comma 1, and again I got something called word to count of hello which has a specific value of 1. So 1 plus 1 is equal to 2. So word to count of hello now will have something called 2, which is its value, right? So that's it. This is the block that is pretty important for us in our reducer code. This is the main thing that we got to understand, because in my first iteration what happens when hello comma 1 comes, hello will go to word and count will go to 1. And here in try except block what happens is it will, in first iteration this will not be satisfied because word to count of hello is not there. So we got to store something into word to count, right? In this particular block this will be stored word to count of hello equal to 1. So we are storing 1 as a value to the key which is hello. So when hello comma 1 comes once again, then that will be handled in my try block, which adds up the values for this particular word, in our case which is hello. So the final value would be hello comma 2, right? And my final output would be for each of the keys it is printing word comma word to count of word, which would be the actual count. So I'll get hello comma hello tab space. That's what I'm printing. Yeah, let's see that while executing. I have my mapper output which we have already seen, and then I'm just executing here as python reducer.py. There you go, that's the output. So we are adding up all the words we are adding up the values for each of the word and we are printing the output. That's how we got my reducer output. This is local testing of my MapReduce code. So how do I execute that in MapReduce real style, like invoking mappers and reducers? How do I do that? Like I said, we have something called streaming concept, using which I'll have to do that. So before doing that, I'll just put this sample.txt into HDFS path, Hadoop FS hyphen put this sample.txt into user Surya path. So it's already existing. So what I got to do is Hadoop FS hyphen rm user Surya sample.txt. Okay, I'm just putting it once again. Yeah, I have put it. Now I will execute my MapReduce code. So if you could see here, I'm using something called streaming, a jar of streaming. This jar is something which suits to my Hadoop version, which is 0.20.2, and CDH3U2 is my version of CDH3 which I'm using, but it's a jar file, Hadoop streaming jar file. I'm using some file which is my mapper code. I'm using another file which is my reducer code. I'm using something called input file which is sample.txt. My final output would be storing in Surya output path. Yeah, let's execute this. So you should see this writing this mapper and reducer in Python is pretty much simple when compared to our Java code. But what happens is when you are writing your code in Python, your Python code has to be converted into Java bytecode. So it might degrade your performance to some extent, but the time taken to develop your code will be very less. So here is my output. Let's see our output file here. So this output file should contain the actual output of your MapReduce, right? So when I cat this particular part 000 file, I should get my actual output content, which is sorted and displayed. You could see here the capital letters sorting in alphabetical order will be getting, and then the small letters, the words which are starting with the small letters would be coming. Yeah. So this is how we write MapReduce using Python. We have a concept called streaming. So we can use this streaming concept to write our MapReduce code in Perl, C and CPP as well. C and CPP we have concept called piping. Hope you had enjoyed this video. Thank you so much for watching this. Bye bye.